Galileo Galilei, born in Pisa, Italy in 1564, became a giant in the history of science. His discoveries reshaped our understanding of the universe. Galileo challenged old ideas and opened new paths of inquiry. He is often called the father of modern science. Galileo's father, Vincenzo, was a musician. Vincenzo wanted his son to study medicine. Medicine offered a more promising career path than music. Galileo, however, was fascinated by mathematics and the natural world. Galileo enrolled at the University of Pisa to study medicine. He soon realized his true passion lay elsewhere. He was drawn to the elegance and logic of mathematics. He began to question the traditional scientific theories taught at the university. Galileo's inquisitive mind and keen observations set him on a different course. He embarked on a journey of scientific exploration that would change the world. His work laid the foundation for modern physics and astronomy. He is remembered not only for his discoveries, but also for his courage to challenge established dogma. While at the university, Galileo made a significant observation. He noticed that a chandelier swung with a regular rhythm. This rhythm seemed to stay the same, regardless of how widely the chandelier swung. This observation sparked his curiosity. Galileo conducted experiments with pendulums to investigate this phenomenon. He used his pulse to time the swings. He discovered the principle of isochronism. This principle states that the time it takes for a pendulum to swing back and forth is constant, no matter the arc of the swing. Galileo's discovery of isochronism had important implications. It led to the development of the pendulum clock. Accurate timekeeping was essential for scientific observation and navigation. Galileo continued to challenge the accepted scientific doctrines of his time. He questioned the Aristotelian belief that heavier objects fall faster than lighter ones. This challenge would lead him to his famous experiment at the Leaning Tower of Pisa. The chandelier observation was a pivotal moment in Galileo's life. It demonstrated his keen observational skills and his ability to find patterns in seemingly mundane occurrences. The swinging chandelier sparked a curiosity that would drive his scientific pursuits. Galileo's experiments with pendulums were not merely about understanding their motion. They were about understanding the fundamental principles governing motion itself. He realized that motion could be measured and analyzed mathematically. The discovery of isochronism was a testament to Galileo's rigorous experimental method. He didn't just observe, he experimented, measured, and analyzed. This approach formed the bedrock of his scientific methodology. The pendulum, once a simple object of curiosity, became a tool for scientific inquiry. Galileo's work paved the way for the development of more accurate timekeeping devices, revolutionizing fields like navigation and astronomy. One of the most enduring scientific beliefs of Galileo's time came from the ancient Greek philosopher Aristotle. Aristotle claimed that heavier objects fall faster than lighter ones. This idea was widely accepted for centuries. Galileo, however, doubted its validity. Legend has it that Galileo tested Aristotle's theory with a public experiment. He dropped two objects of different weights from the top of the Leaning Tower of Pisa. The objects, contrary to Aristotle's theory, hit the ground simultaneously. While the story of the Leaning Tower experiment is likely apocryphal, Galileo did conduct experiments with inclined planes. These experiments demonstrated that the acceleration of falling objects is independent of their mass. Gravity, he showed, acts equally on all objects. Galileo's challenge to Aristotle was a bold move. It challenged the established scientific authority of the time. His experiments with falling objects marked a turning point in the understanding of gravity and motion. Section 5. The language of motion. Galileo's experiments with motion were groundbreaking. He was one of the first scientists to systematically study how objects move. He used inclined planes to slow down the acceleration of falling objects. This allowed him to make more accurate measurements. Galileo's observations led him to formulate the law of falling bodies. This law states that the distance traveled by a falling object is proportional to the square of the time it takes to fall. This was a revolutionary concept. Galileo also studied projectile motion. He showed that the path of a projectile is a parabola. This discovery had important implications for ballistics and understanding the motion of celestial bodies. Galileo's work laid the foundation for the science of mechanics. His emphasis on observation, experimentation, and mathematical analysis transformed the way we study motion. He provided the tools and concepts that would later be refined by Isaac Newton. In 1609, Galileo heard about a new invention from the Netherlands, the telescope. He immediately grasped its potential for astronomical observation. He built his own telescope, grinding and polishing the lenses himself. Galileo's telescope was not the first, but it was significantly more powerful than any other at the time. He pointed his telescope skyward and made a series of groundbreaking discoveries. His observations of the moon shattered the prevailing belief that celestial bodies were perfect and unchanging spheres. He saw mountains, craters, and vast plains on the moon's surface. Galileo's telescope revealed a universe far more complex and dynamic than anyone had imagined. His observations challenged the long-held geocentric view of the cosmos and provided support for the heliocentric model. Galileo's telescope unveiled a universe teeming with wonder. He observed that the Milky Way, a hazy band of light across the night sky, was actually made up of countless stars. He discovered 4 moons orbiting Jupiter, now known as the Galilean moons. The discovery of Jupiter's moons was a major blow to the geocentric model. It showed that not all celestial bodies revolved around the Earth. Galileo also observed the phases of Venus. These phases could only be explained if Venus orbited the Sun, not the Earth. Galileo's observations provided compelling evidence for the heliocentric model proposed by Nicholas Copernicus. Copernicus argued that the Earth and other planets revolve around the Sun. Galileo's findings sparked controversy and brought him into conflict with the Catholic Church. Galileo's discoveries transformed our understanding of the solar system and our place within it. He opened our eyes to the vastness and complexity of the cosmos. Galileo's support for the heliocentric model put him at odds with the Catholic Church. The Church held that the Earth was the center of the universe, in accordance with its interpretation of Scripture. Galileo's views were deemed heretical. In 1616, the Church banned Galileo from teaching or defending the Copernican system. Undeterred, Galileo continued his research and published his dialogue concerning the 2 chief world systems in 1632. This book presented a compelling argument for heliocentrism. The publication of the dialogue led to Galileo's trial by the Roman Inquisition in 1633. He was found vehemently suspect of heresy and placed under house arrest for the rest of his life. Galileo's trial remains a cautionary tale about the conflict between science and dogma. It highlights the importance of intellectual freedom and the pursuit of truth, even in the face of opposition. Despite the restrictions imposed on him, Galileo continued his scientific work until his death in 1642. He made significant contributions to the understanding of mechanics, optics, and astronomy. His legacy continues to inspire scientists and thinkers today. Galileo's greatest contribution was his pioneering work in the scientific method. He emphasized observation, experimentation, and mathematical analysis as the foundation of scientific inquiry. His approach revolutionized the way we understand the natural world. Galileo's courage to challenge established authority and his unwavering pursuit of truth paved the way for modern science. He is remembered as a giant of scientific thought, a rebel who dared to change the cosmos. Galileo's story reminds us that scientific progress requires not only brilliant minds, but also the courage to question, to explore, and to seek truth wherever it may lead.